And so let me brief some of these we looked at last time. So Mariner 6 and 7 were very similar to Mariner 4. They were both flyby missions. In this case, they were both successful, and each flew past the planet in slightly different areas. But if you look at the photographic results from Mariner 6 and 7, it looks very similar to what we saw with Mariner 9. A lot of crater morphologies, a lot of terrain that really looks battered and old, like nothing much had happened to it for a long time. There were some indications from 6 and 7 that there was something going on besides just a cratered moonscape, but clearly most of the views of the planet were these heavily cratered areas with some amount of weathering, because we know Mars has some atmosphere compared to the Moon. There's going to be some weathering going on, more so than on the Moon, and so it's not unexpected that some of the cratered areas are a little bit more eroded. There were some areas that were just looked kind of smooth, so clearly something had happened to erase craters in a big way, more so than just a little bit of weathering. But there was no view of mountain ranges and valleys like we find on the Earth. So no thought that Mars had any kind of plate tectonics. There was this area called chaotic terrain, which they really couldn't interpret from the few images that they got from Mariner 6 and 7. So somewhat maybe a confused view, but pretty much reinforcing what we had found in Mariner 4. And it's just really kind of the luck of the draw that these three missions all went over the most boring terrain on the planet. Well, not boring. I mean, craters are interesting, but the terrain that was most depressing for those who were interested in life on Mars. Mariner 9 begins to be a different story. Because in this case, we're talking about going into orbit, and it was early 70s when we had Mariner 9 go into orbit. Oh crap! Okay, I won't the details of the spacecraft, but after all this buildup, we're finally going to send a craft into orbit around Mars. A few months before Mariner 9 and the two Soviet orbiters get to Mars, a dust storm starts up in the southern hemisphere of Mars, and this is one of those dust storms that develops into a planet-wide global dust storm. So when Mariner 9 and the two Soviet probes went into orbit and pointed their cameras down at the planet, there was nothing to be seen but dust. I mean, there were no features that could be detected at all. The two Soviet missions were pre-programmed. Their computers, didn't have the ability to be overwritten from ground control. So they went through their pre-programmed series of observations, taking pictures, making measurements, and so forth, and ended up basically dying before the dust storm passed. And so they didn't actually return much data. NASA put Mariner 9 basically into quasi-hibernation and said, okay, just keep orbiting the planet, conserve your fuel and everything. And gradually over time, the dust storm broke and the dust begins to settle out of the atmosphere. And this is the first indication that there is any kind of structures to be seen. So the dust is beginning to settle. What do you see in this picture?
It looks kind of like craters, but I'm assuming it's volcanoes.
Yeah, there are these things that begin to poke up out of the dust. So obviously these are very tall structures, and they are craters. They're just not impact craters. There's, as you mentioned, volcanic craters. So basically the first real interesting feature from Mars that was seen from any of these spacecraft were these volcanoes that clearly must be huge in order to stick up miles into the atmosphere to be the first things that show up as the dust begins to clear. And indeed, they are some huge volcanoes on Mars. Remember, what was the story that Lowell had made about topography on Mars?
It didn't have any mountains because it was too small for life.
Okay. So too small to rumple, it didn't have any mountains, relatively flat. When Lowell and others looked at the Terminator through their telescopes, they didn't see any peaks, crossing over that line between light and dark. And so the dogma was Mars has no mountains. That's the story, that's the setting for a lot of the Mars science fiction in the early 20th century. And when we finally get to Mars and can take a look, Mars actually has some of the largest and the largest volcano in the solar system. So, here we have Olympus Mons. Mons just means mountain. It is, if you superimposed these areas over a map of the United States, those three initial volcanoes that were sticking up out of the dust would be on this order of size, and Olympus Mons is even larger. Actually, if you moved Olympus Mons, it would cover entirely the state of Arizona. So a fairly impressive feature. These are all shield volcanoes like the Hawaiian Islands, but on a much larger scale. And one of the next prominent features that was noticed is a huge canyon system that, if superimposed on a map of the United States, would stretch from coast to coast. Okay, this is the Valles Marineris. Complex. So, we talk about the Grand Canyon in Arizona. It would be, this little tiny thing compared to this Grand Canyon on Mars. Morphologies that look like ancient riverbeds. And we'll talk in much more detail about these valley networks and outflow channels. But clearly there's clearly no water on the surface of Mars today. Or if there is, it's in small, tiny packets under very unique conditions. But, planetary scientists start looking at features like this, and what's your interpretation of these structures? Plateaus like in here? Like here maybe is, this would be actually lower elevation in this view, and elevation slopes downhill from lower left to upper right. Clearly there's no water carving these as rivers today, but when we saw these kinds of images, Mars all of a sudden became much more interesting because it looks like there was potential for there to be more Earth-like water cycle on Mars in the past to have created these rivers. Now there were alternate explanations, alternate hypotheses. I mean, these could have been carved by winds blowing over billions of years. These could have been carved by lava flows. These could have been carved by liquefied carbon dioxide. I mean, there's no guarantee that it would necessarily be water, but brings up the possibility that Mars in its past used to have rivers and streams. Same thing with the outflow channels. Again, we'll these in much more detail, and these valley networks. Much better view of the polar caps to begin to see, the presence of different kinds of ices, water ice and carbon dioxide ice at the poles. So clearly Mars is not the same kind of dead world that the Moon was, and that was our view after Mariner 9. I won't take the time to necessarily go through all of these science results, but you'll have a recording of this. In addition to taking interesting pictures, there's a lot of work done on what's the atmospheric composition, what's going on with climate. We're beginning to start to get to build an understanding of Mars climate and how it might be similar and different to climate on the Earth.